Well, good morning, everyone, and welcome to the Abrams Planetarium Facebook Live event for today. They came from outer space, episode 3. We're going to talk about space dust today and how we can find space dust, where we can locate it, everything along those lines. Now, as we've talked in the past, this is a stony meteorite, and you can see those circular pieces there that we call chondrules. Stony meteorites are called chondrites. The shiny flecks that you see, iron nickel. And if in some cases you can separate out those chondrules because some meteorites are friable. And that means that they break apart real easy in your hand if you run your thumb over it or whatever. And then we're left with, you could see these circular pieces here, which are basically stardust, space dust. Asteroids aren't stars, but this is a dusting material that would come together and form an asteroid or a planet over time, whatever you get. And you can see how tiny they are. They're not very large. Well, believe it or not, there's something even smaller. So I'm going to introduce you to a gentleman who has taken up this cause since 2015, basically. In 2009, he says that he was sitting on his porch having a drink, and something fell out of the sky and landed. It was a black dot. And he had always been curious about things, and he started searching for something that's been very difficult up until now to even quantify, and that's stardust. And his name's John Larson. He's a Norwegian. This is his book, On the Trail of Stardust, the guide to finding micrometeorites, the tools, techniques, and identification, because many of these can be broken down. Not only is it the micrometeorites that are extraterrestrial, but we also have to deal with all of the terrestrial material, and that can include beads off of roofs, firework debris, all things like that that burn and form little droplets, spherules as they're called, and deposit themselves in the atmosphere. And when it rains, or throughout the day, it deposits them on our roofs, in our yards, on our driveways, you name it. So one of the other books I'll share with you too is John Larson in Search of Stardust. This is a photo book that he's put together. Mind you, these pieces are the size of a tip of a pin or the tip of a toothpick. They are that small, and these are enlarged photographs right here. And so I'll share some things out of that with you as well today. But John started out his most recent book, and he has another book that's coming out in just about 20 days, I guess. I'm looking forward to that. But John started his introduction to On the Trail of Stardust with, it is the oldest matter there is. Nothing has traveled further. It is the building blocks of galaxies, planets, and even humans. We are all made of stardust. John has conducted over 1,000 field searches in more than 50 countries and on 6 continents in search of what he's looking for. In 2015, they were able to confirm the first urban micrometeorite was found. And that was John working with a university and their microscopes and that. The spherules that I mentioned, or spherules, are raindrop formation type. So when a meteor comes through the atmosphere, as we've talked, it heats up and puts a fusion crust on the outside of it, but it also burns off material as it's coming through the atmosphere. And since these particles are so tiny, smaller than the tip of that toothpick, they can become molten and shaped and formed, so they can glide through the atmosphere as they're being heated. And it can move a core that they have, because some of these have a little tiny drop of iron at the top of them that you'll see in some of the photographs. And so they glide through there just like raindrops are formed, and then they actually look like raindrops in some ways. And the size of these, as I mentioned, smaller than the tip of a toothpick, most generally are between 200 and 400 microns. Now, to put that in perspective, if you've got a millimeter ruler, a 0.5 millimeter, so just start at the beginning and go to half between that and the next line, and that is 500 microns. So it gives you some size perspective. 200 to 400 microns is even smaller than that. One of the things that is difficult because of both terrestrial and extraterrestrial matter that you may be looking for is separating out the extraterrestrial dust from the terrestrial imposters, as John puts it. And just imagine, more than 100 metric tons of cosmic dust comes through the atmosphere on a day. That's a lot. Continuing to build our blue dot in the sky. And then when you think about the Earth being 70% water, so you've only got 30% land masses that you can go out and search. Most of this lands within our oceans. In the statistical data that John has put together in his book, he makes the point that you can expect one extraterrestrial with a diameter of 0.1 millimeter, 1/10 of a millimeter per square meter per year. So, you know, when you think about that, it takes a while for all of this to add up. So let's get to where can we find these. I actually went out to my downspouts that discharge the water off the roof through the gutters. I have capped gutters. So I went to the end of the downspout, and I have catch basins on the downspouts. They've been there about 20 years. And I picked up dirt to go through that was discharged at the end. So, and I went through and bagged it up. As you can see, I've got a jar full here as well. So, so you can pick it up there. Some of the best places to get them are flat roofs that you see on commercial buildings. And if you can get permission, or if you know the owner or a janitor, or perhaps you work at a facility that does have a flat roof, you could go up there and be very careful when you go up there, because you know it's open to the edge. The edge doesn't have a a 4 or 6 foot fence going around it. Sometimes, depending on the material that the roof is made of, whether it's PVC or tar paper or tarred, you have to be careful because you can cause perforations in the roof covering, which means it'll be wet inside when it rains next. Some of the best places to look are near the drains, or at the edges and in the corners, or at the places where there are ridges where the roof covering overlaps. And those are the best places because they catch everything. So you'd want to take up a broom. You could take up a magnet, but if you're looking at collecting a 5-gallon bucket of debris, you're not going to be using a magnet directly on the roof just to pull the magnetic pieces out while you're up there. If there isn't as much debris, you might try it and do it. But otherwise, you're going to use a broom, a dustpan, things like that, to sweep up all of the dirt and debris that's on the roof in the area. And for health, safety, and environment concerns, you're going to want to be sure to wear sunscreen. You're a little bit higher to the sun. You want to be aware of bird droppings, which can represent a biohazard concern. So wearing gloves and a dust mask. And John suggests similar to the N95 type, which are reserved right now for our healthcare workers on the front line. Maybe some disinfecting material, rubbing alcohol, things like that, so you can clean things off when you're done. And then you're also going to be cleaning the micrometeorites and all the debris that you brought off of the roof so that you can separate it down to that size where most micrometeorites are going to fall, and that is in the 200 to 400 micron range. If you're once you're done, and let's just say you take a small sample like this, and actually I have these little jars here that you could see that make it real easy to put material in and look at it. What you want to do maybe is there are a couple of different options you can go here. One, you can take your a small sampling of what you got off the roof, spread it out on a piece of paper, take a rare earth magnet, a very powerful magnet, and there it is. Powerful magnet like that, and you can see, watch this. Magnet just moves things around. Okay, so every particle that is now in this container is at least magnetic. And so as you were to sieve, you can use a sieve. You can use a bucket and water method to separate it out until the water's completely clear. And if you really want to get into detail, the best thing to do is to pick up John's book. It's relatively inexpensive. I think it's around, well, this copy says $20 in the United States, but I know they're available on Amazon for about $13 a piece. And that way, he'll walk you right through the steps for water separation of these, or the magnetic separation that I just did. That's here. You would want to, some of these particles are, let's see, are larger than the tip of my toothpick. Okay, so you're gonna use a sieve to get these down, probably in that 200 to 400 micron range. And you can find sieves online and things like that. Sometimes you can use a flour sifter, which will do some of the work. Or you can just spread these out on a 3x5 card like this underneath a microscope and crank up the magnification on it and try to separate out and see if you can find any of those spherules that we're talking about. So what I did is just and I don't know if you can see those very well or not, but just a few. Wow, real tiny, aren't they? Right there at the bottom. As I separated some of these out, and I've gone through, and these are almost clear, like quartz. And you can also find, and I don't know, there's only 2 pieces in here, but you can see them right there. And those are pieces of the asphalt from the roof. So you can separate all of those out, but what you want to do is really look at the small pieces. John has some photographs in his book that are just magnificent. And let me show you a couple of things. So John's got another method here. Sorry, I'm just going to back up just a little bit. Talks about using a very large rare earth magnet like that to collect a lot of specimens, you know, if you're working on it and dumping them to do that. And what he was suggesting is you could take a Ziploc baggie, toss your magnet in the Ziploc baggie like that, place the magnet in the Ziploc into a larger bag like this. Okay, and then what you're going to do is you're going to do a sweep. You can see it just picked them right up. You're going to do a sweep, and what that allows you to do, if it's a lot of material, is whatever is stuck to your magnet here, you take another baggie, you open that up, you stick now both baggies and the magnet in here, and you release that outer baggie that's around the magnet very easily, and all the material will drop into the main bag. So makes sense, because if you've ever tried to clean off one of these magnets after getting iron filings or anything in them, it takes a while, and sometimes you just don't get them all off. So with that said, I'll share some of the images with you out of John's book, just so that you get an idea. Again, here's that flat roof with the drain that you see. There's an image of material that he's collected off of that roof, and it shows a glass micrometeorite with an iron core in it, which is pretty cool. And you can see the variety of things you might find. Here's the meteorite in the bag trick. When you're separating these out, you can use some chopsticks that go right down to a fine head. Just have a little bowl of water and have one of them dry. The dry one, you can kind of move things around underneath a microscope with the dry one. And when you see something that looks like a possible micrometeorite, wet the tip of the wet one, just tap it and go in there, and the water will pick the specimen that you're looking at, that you want to grab, right up. It's a shame that micrometeorites are so small, but they're very special. And you can see some of the different textures that micrometeorites have. And just like an oriented meteorite, because that's basically what these are coming in, just in the micro form, they all have a nice shape, shield, or rounded to them. We were talking about those little tiny beads of iron at the tip of these. That is nickel iron, and that's what makes them magnetic. Aside from all the terrestrial debris that accumulates. And here's an enlargement of another one, right there. And here's another enlargement, right there. And you can see the nickel iron on the very top of this one here. A couple more photos out of John's other book, one of his other books. Just absolutely stunning in miniature. So that's an adventure into micrometeorites. If you've got a good stereo microscope, 63 power magnification, you can use a low budget USB digital microscope to help with the sorting process and everything. You just need to separate out the particles. You can label the containers where they came in, as you saw when I labeled where my specimen came from, so that I know, and I can just tuck this away for a while, because it would take a while. Probably not so much after I clean it out, but take a while. You can find different types of storage containers like this to put them in. But again, just remember they are very, very small. And when we talked about the other types, the terrestrial material, that can be industrial, it can be magnetic. There are types that are massive iron. There are nuggets of beads and cores. There's welding shop sparks that fly off, and some of it goes into the atmosphere and gets deposited elsewhere. There's glass and mineral wool, fireworks, and many, many more. John has put together a Facebook page that is very informative. And let's see, there's my sheet on that. The name of the Facebook page is Project Stardust. Project Stardust. So if you want, you can check out Project Stardust. He has postings almost daily on there. Photographs, talks about collecting, and the success of other people have had in collecting micrometeorites. It's a great thing for kids to try if you want to keep them busy for a couple of hours. I have a granddaughter who's doing this, and she really enjoys it. So in that way, especially in these times, gives them something to do, something to look for, and with not much of an outlay of money at all. You can collect them from the end of your downspout, or maybe get into the gutter area itself if you don't have caps on them. Again, if you have access to a flat roof of a commercial building. And keep in mind that, let's say if that commercial building has only been there 10 years, and if you did find a micrometeorite, you would know that that micrometeorite fell to Earth in the last 10 years. Okay? If the building's 50 years, same thing applies. Micrometeorites have been found in Antarctica. and they can be anywhere from a year old to 1,000,000 years old in that untouched tundra of ice that's down there. And even some of the Arctic explorations, when they've drilled it down deep into the ice core to see what our atmosphere was like and everything at that time, they have found micrometeorites in the bottom of the water that they've heated up. So they're out there. It's just like finding a large meteorite in a forest, okay, in a climate that's damp and wet, or has been left for a period of time. Looks like a terrestrial rock and nothing special, and very difficult to locate. Micrometeorites are the same way, kind of a needle in a haystack. But I think it teaches us about all of the debris that's in our atmosphere that has been created since the Industrial Revolution, going back even into the 18th century, so forward. And you might be surprised. And micrometeorites are just kind of like the icing on the cake. What a thrill to be able to find one. More of a thrill as it goes to keep adding to the diversity of your micrometeorite collection. And it's also something that we can do on our own. We don't really need a lot to do it, but we can do it on our own. One of the drawers in our new exhibit, when it opens, will be devoted to this subject as to how often meteorites are falling on Earth and that. So we'll also include some of the terrestrial material within the exhibit so that you could see the difference between them. Although they may look the same, they're certainly quite different. I would, at this time, I really, doesn't look like we had any questions right now, but I would invite you to visit the planetarium once it's back open again. Right now we're shut down like everyone else, and if you would like to make a donation to the planetarium, we would certainly appreciate that. I know that the director will probably put a link on the site. And I see that she's got a link to the Amazon site as well on there. So that if you wanted to check out John Larson's book, you can. But continue to check out Abrams Planetarium Facebook page, because we have the readings that go on for kids and that, and also announcing other events that may take place. John French takes us outside. Experiments are performed online so that you can see those. So please be sure to continually check out our webpage. With that, next week we'll be talking about meteorites from the asteroid Vesta. And I'll be showing you examples of meteorites that have come from Vesta. And we'll talk about the different types and the asteroid recovery programs and things like that, where they return samples to Earth. So with that, I'm Craig Whitford. I'm the Meteorite coordinator, volunteer at Abrams Planetarium. And I wish you well, stay safe, and keep your eyes to the skies. Have a great week.